One of the things that you'll see a lot in statistics is this thing called linear regression. And the key idea here is that, let's say we have a bunch of data points and they come in several quantities, let's say x and y here. And we would like to quantify, we would like to find the relationship between x and y. We would like to be able to predict y based on the values of x. So what we usually do is that we will plot these data points on the xy plane. Let's say our data looks something like this. And then we will find the equation of the line that would best fit all these data. So for our example, we only have 3 data points. We have 2, 2. We have 3, 11, let's say it's way up here. And then we have 6, 12, something kind of like this. You can kind of see that these 3 points, they do not lie on a line. But if we were to guess, I can probably say that a line that would best fit all these 3 points is probably going to be something like this. Now, there's a lot of statistical programs that can do linear regression and find the equation of this purple line for you. But for now, let me actually just go ahead and ask Wolfram. So I would like to do the linear regression. And then my point is going to be 2, 2. And then, let's see, 3, 11. And then 6, 12. Okay, so Wolfram understand my query then. So the data is the 3 points, and I like to find the linear function. And then it shows me the graph of the 3 points that we have earlier and the line, and the equation is going to be 2x plus 1. Now let me actually try this again in Excel. So my data point is going to be 2, 2, and then 3, 11, and then 6, 12. I'm going to ask Excel to insert a scatter plot for me, and then I'll ask Excel to add trend line and also show me the equation. Okay, so this is the 3 data points that I have, and we get the same equation that we get from Wolfram earlier, which is just 2x plus 1. Yeah, so indeed the equation of this purple line that we need is just y equal to 2x plus 1. But what does all this have anything to do with linear combination and span that we see earlier? Well, you see, when we want to find the equation of this purple line, what we are looking for is we are looking for the equation y equal ax plus b. And the unknown that we have here is a and b. We can kind of see this a and b as a variable that we are trying to solve. And we actually knew a couple values of x and y here. So what we can do is, we can actually try to plug in these values of x and y and see what equation are we going to get. Now then, if we try to plug in x equal to 2 and y equal to 2, I'm going to get that 2 is going to equal a times 2 plus 2, or 2 is going to equal to a plus 2. If I try to plug in x equal to 3 and y equal to 11, I'm going to get that 11 equal to 3a plus 2. And then, wait a minute, not plus 2 plus b. And then for the last data point, if I plug in x equal to 6 and y equal to 12, I'm going to get 12 equal to 6a plus b. So now, we actually have these 3 linear equations where the variable that I have is a and b. And then I can rewrite these 3 equations as a vector equation. So I'm going to have 2, 11, 12 has to equal to a times 2, 3, 6 plus b times the vector 1, 1, 1. So the linear equation that we have earlier is the same as this vector equation that we have. So in a way, doing linear regression is kind of like solving this system of linear equation. And let me actually move this 2, 11, 12 to the right hand side. So this is in the form that we are familiar with. Now then, you can probably kind of guess that this equation is not going to have a solution because the 3 points that we have earlier, they do not lie on a line. There's no a and b that would make this purple line go through all the 3 points. And in fact, if we plot these guys on the 3D graph, I'm going to see that the span of these 2 vectors, 2, 3, 6 and 1, 1, 1 is going to be a plane, and 2, 11, 12 is going to be a point outside the plane. And this is what we are looking at here. So the plane that we have, this is the span of 2, 3, 6 and 1, 1, 1. So 1, 1, 1 is the little black vector that we have here. and 2, 11, 12 is the orange point, and we can kind of see that it's kind of way outside of the plane. So what linear regression is doing for us is that even though this equation has no solution, but the best approximation that we can have is that I'm gonna let the value of A equal to 2, and I'm gonna let the value of B equal to 1. So let's kind of try to do that here. If A is equal to 2, I'm gonna have 236 times 2 plus 111 times B, which is 1. So what I'm gonna get is 2 times 2 plus 1, so that's a 5. 3 times 2 plus 1, so that's a 7. And then 6 times 2 plus 1, so that's a 13. Now, if we plot 5, 7, and 13 on the same graph that we have from earlier, I'm gonna get this green point here. And we can kind of see that the green point, 5, 7, and 13 lies on the plane. And it's actually going to be a point on the plane that is closest to the orange point that we have from earlier. And we are going to see a couple of ways that we can find the coordinate of this green point using other methods later.